Good afternoon, everyone. How are you doing? How are we coping with this present economic situation? My name remains Banjo Olaleko Peter, BSc Math OAU, MBBS, LAUTECH in view. This afternoon, once again, I want to check equation of uniformly accelerated motion. Those equations of motions, how we derive those equations and how we use it. It is going to be two sections where we are going to derive. Then later we see how we apply those equations of motion in solving questions. But the equation of motion, we start with the acceleration. We will talk of acceleration. Acceleration, the rate of increase in velocity, the change in velocity per unit time. When you have an initial velocity u, you have the final velocity v. The change in velocity, putting into consideration the time it takes for the velocity to change, is the acceleration. So we can have a as normally, mathematically, as the change in velocity as v minus u divided by t, where our u is our initial velocity, our v is our final velocity, and our t is our time taken. Now, if we have a as v minus u over t, by the time we cross multiply, we can have v minus u is equal to a t. And of course, if we transfer minus u to the right hand side, we have v is equal to u plus a t. This one is our usual first equation of motion. Our usual first equation of motion. Now, we know that our average speed, normally, our average speed can be total distance over the total time taken, which you can write as s divided by t. If a body is undergoing uniform acceleration, for a body that is undergoing uniform acceleration, we can also have average speed to be initial speed plus final speed over 2, which means we can write it as u plus v over 2. Can I label this as alpha and label this as beta? By the time I equate alpha and beta, equating alpha and beta, I will have that s over t is equal to u plus v over 2. And of course, by the time I try to transfer t towards this side, I can have our s equals u plus v over 2 multiplied by t. S is equal to u plus v over 2 multiplied by t. Now, since I know this one is, I say first equation of motion, and I label it as 1. I know my v equals to u plus at. I can say substitute v equals to u plus at in equation, I'll call it equation asterisk, and I will label this one as my asterisk. I will label it as my asterisk. So I want to substitute v equals to u plus at in equation asterisk. So in this one now, anywhere I see v here, I will replace it by u plus 8, so that we can have s is equals to, this is u plus, instead of v, u plus 80 divided by 2. That's s equals to u plus 80 divided by 2 multiplying t. So that from here we can have s equals to, if we add u and u, we have 2u plus 80 divided by 2 multiplied by t. And automatically we can break it, so that we can have s equals to 2u over 2 plus 80 over 2 multiplying t. So from here we have our s is equals to, now by the time we say 2u divided by 2, the 2 will cancel out, leaving u. So we have u plus, now 80 over 2 here multiplying t. If we use t to open that bracket, you have s equals to ut plus 8t squared divided by 2. And of course, the implication is that we can write this as ut plus 1 over 2 8t squared. So this s is this. So we have s equals to ut plus 1 over 2 8t squared. This is the one we commonly refer to as the second equation of motion. The second equation of motion, I can label it as number 2. Now, what would have happened if I have squared equation 1? So we want to square equation 1. So I will just say by squaring equation 1, by squaring equation 1, if I square equation 1, what I will have is that I will have v square, as by square this left hand side, v square is equal to, I will put this in bracket, u plus 8t, everything all square. And if I do that, I will write this one twice. I will have v square equals to u plus 8t multiplied by another u plus 8t. And this implies we have v square equals to, by the time this u multiply this u square plus, by the time this u multiply 80, u 80 plus, by the time this 80 multiply this u, another u 80 plus, by the time this 80 multiply this 80, a square t square. The u here multiply this u first, then later the u here multiply the 80, giving us the first two terms. The 80 here multiply the u, giving us the third term. The 80 multiply the last 80, making the last term. So from here, we now have our v square is equal to u square plus this one, you add it to this one, and the result is going to be 2u80 plus this one will give us a square t square. Now from here, we have that v square is equal to u square plus, now here I want to do one factorization here. I can see that I have a here, I have a here. Let me bring a out first, so that I can have 2ut plus at squared. Now I want to bring out these two. Well, I have 2 here, I want to bring it out, but I don't have 2 here. Since I don't have 2 here, it becomes over 2 straight away. So if I bring 2 out, you have v square equals to u square plus, I bring 2 out, 2a, open bracket, this remain what? ut plus, this one become at squared divided by 2. And if you take a look at it very well, I can rewrite the one inside this bracket as v square u square plus 2a into bracket ut plus 1 over 2at squared. Now, you will agree with me that this ut plus 1 over 2at squared is the right hand side of equation 2 here. ut plus 1 over 2at squared, which is equal to s. So it means ut plus 1 over 2at squared is my s. So all what I have here represents s. I will just attach it to this and say therefore I have v squared is equal to u squared plus 2as. V squared equals to u squared plus 2as, which I will call this one as equation 3. Now the summary of everything is that the summary we have, the summary is that we have the first one as v u plus at. We have the second one as s ut plus half at squared. We have the third one as v squared equals to u squared plus 2as. I'll give you the supplementary one that says s equals to u plus v over 2 into t. If you look at this very well, here this one doesn't have s. Here this one doesn't have v. Here this one doesn't have t. Here this one doesn't have e. But everything has u. We have u here, we have u here, we have u here, we have u here. Now, when you read your question, it depends on the question. When you see from rest, you have your initial velocity as 0 meter per second. So stay tuned for how we apply this equation all these four equations in solving question. Good afternoon.